You said 3 questions?
Yeah.
Right.
So you had to do all.
But you would like, I'm really liking elasticity. I really like that opportunity of elasticity in the line. So when I do like one question elasticity and freaking elasticity.
We have a sub meeting. I just
I can't.
I'm not doing it for today.
But it's.
Oh, wait, no, I'll do it. I'm even by. I'm in college. That's how that's maybe. I was just gonna say.
Yeah, he does. I'm like, bro.
You want me to go? I'm trying to look. Wait, so.
Well, I told you that.
That's exactly what you said. Right. I don't want to jump the chance. I gotta stop.
My mom got it. Yeah.
All right. I'm going to continue picking out problems from the packet in preparation for your test on Friday. But right now, all these topics are kind of scattered across these different worksheets. Tomorrow, I'll give you 2 additional test reviews that are more compact, so you can see exactly the length and what to expect from your test. I'll give you 2 worksheets. So tomorrow we can work through one of them, and then the other one you can do on your own in preparation Thursday night, or you can come in Friday morning and we can go through it together Friday morning. So if you guys can turn to near the back of your packet here, I want to just highlight what rules that I want you to know. It's not going to be all the rules. So if you can just go to near the back of your packet. Sorry, I didn't number the pages. I think second to last page, maybe. All right, so I'm going to start highlighting the rules that I want you to know. So obviously, we need to know power rule for derivatives. Trig derivatives. I know these only look like 6 rules to you, but these are actually 12 rules in front of us. These all also they also have the integral rules, because the integral rules are just going backwards from right to left. So I'm going to highlight trig integral as well, but I want us to know that I just want you to, it's a good thing, this is good habit to build on the AP exam too. On the AP exam multiple choice section, you just write these rules down, because you know that these are, more than just 6 rules. These are 12 rules, integrals as well. Okay, derivative e to the u, we know that. Natural log, u prime over u. Don't worry about the a to the u. Don't worry about the log base a. Okay. All right, integral rules, power rule, we definitely need to know that. 1 over u du is natural log, make sure we know that. E to the u, we know that. Don't worry about the a to the u. We do have more additional trig integral rules that involve natural log. We're not going to worry about that now. Maybe I'll bring that in later. Don't worry about the arc trig derivative rules. And then we just recently learned the arc trig integral rules. Okay, so if you flip to the very last page, there is a blank sheet as well as a key for all the rules. You can just kind of maybe, or the next day or 2, you can cross out the ones that we don't have to know and just see if you can practice writing out the rules, recalling all the rules that we do need to know. So yesterday, we went through power rule, we did use substitution, we did ones that involve change of variable. We did trig integrals. Tomorrow I'll go through some ones where you have to go through depth integrals. You have to go through plugging the upper lower bound and use unit circle values to evaluate. Well, if we have time, I'll try to come up with one for us to practice. Depth integrals involving absolute value function. This is where you graph your absolute value function, and you know that you're just going to have two triangles that's going to show up. You're just adding the areas of those two triangles. We did second theorem yesterday. We did average value theorem yesterday. Today I would like for us to practice even and odd functions. We'll practice synthetic division. We'll practice complete the square. That involves our trig. And then I think, did we do e to the u problem? Integral e to the u? Okay, if not, I'll come up with one for us to try as well. All right, so now let's go back to our packet. Sorry, all the problems are kind of scattered. Let's see. This page got crossed out because this is our next unit, and this is from AB. I have AB contents in a different order than BC, but I wanted us to use the space to see if we can do an even and odd problem. So if you guys give me a moment here, I want to have you guys copy down this problem for us to try. Okay, we'll do an even and odd together. Okay, so in that empty space with the portions crossed out, can you guys copy down this problem? And then we'll work through it together. Okay, let's do this one here. Okay, so we have, so here are the steps that we want to follow. First is you want to graph your shorter interval first. Not necessarily your smaller area, it's going to be your shorter interval. So whichever spans across the shorter width will be your starting point. And then your second step is you're going to use that shorter interval and you're going to graph the other side, depending on whether it's an even or odd property. And then you're going to fill in the gaps with your larger interval. And the reason that we want to do it this way is because if there's an overlap, then we can just kind of fill in the gaps that are still unresolved or where we don't have any information about. Okay. We always want to read from left to right, otherwise everything is backwards here. So this one is from left to right. This is from 0 to 1. So whatever we see is pretty straightforward, right? That's just going to be clearly below the x-axis, -3. What about this one here? Yeah, this one, that 5 is a little misleading because this is going backwards, right? From -1 to -3. So this is really showing a region of what? -5. So just be aware, right? So I'm going to rewrite this. Even though this is a larger interval, we're going to deal with this later. I want to just make sure I get that out of the way. You want to write it this way so you can be a little bit more clear that that +5 is a little misleading because, yes, going backwards is +5, but going forwards, if we read from left to right, this is really a -5. So we want to be able to read it that way. Okay. All right, so part A, if g of x is even, find the definite integral from -1 to 3 of g of x dx. We'll deal with this later after we get our entire graph to show up. So let's start with our shorter interval. Our shorter interval is from 0 to 1. So 0 to 1, we're going to show a region of -3. Right, now that we have our shorter interval resolved, let's go ahead and graph the other side. Our graph, for part A, our function is even. So what can we put on the other side? Also -3, right? Okay. Okay, so now we can work on the larger interval. So larger interval says from -3 to -1 is equal to -5. So we can fill this in with -5. So if this is -5, what do you know about this side? Also -5. So right now we didn't experience an overlap, but if there was an overlap, then we have to make sure we understand that both of these two regions will add up to that number. Okay, so maybe I can do one with you where there's an overlap tomorrow. But right now there's no overlap, and we don't want to just blindly add up all these numbers. We only want to add the values that they're asking us to add. So it's between -1 and 3. So just those values together. Right, any questions? Part B, g of x is odd. So again, we start with a shorter interval. As soon as we have the shorter interval filled out, we want to go ahead and do the other side, get that get the property to show up. It's an odd function, so what do we know about the other side here? Positive 3. Okay, we know the integral from -3 to -1 is a -5. And this is -5. What can I say about the other side? Positive 5. Equal but opposite. Okay, so now we're just going to add between -1 and 3. And get 5. Let me see. Okay, back to worksheet 2. Let me pick out some even problems. I just want to make sure I go through some of the more recent topics with you. So this is worksheet 2. This is part of your homework pages, but let's do number 8. All right, look at this problem here. We should be able to tell what process is this going to involve here. Yeah, synthetic division. So synthetic division has a certain look to it. It's always going to be a rational expression. There's always going to be 2 terms in the denominator, like an x plus 1 or x minus 5. And we're going to go through synthetic division to kind of split up our problem. And then a lot of times our problem will just be a bunch of power rule, and the last term will be natural log. All right, so let's do this one. Careful that we're accounting for any degrees that got skipped over, but this one, there's no issue. Degree 3, degree 2, degree 1, constant. There is no placeholder that we need for any degree that got skipped over. Now assign the degree for all of our terms. We know we're dividing by x, so every degree is going to fall by 1. So we're going to start off with x squared, and we're going to keep decreasing the degree from there. And the last term is the remainder. Now it becomes a lot easier because all these are just nice power rule terms. And the last one, a little bit of u substitution, ends up being natural log. Okay, let's skip down to number 12. 12 is involving e to the u. So if we see that, if we let the exponent be our u value, then we can match that with e to the u rule, go through u substitution. And then once we resolve our antiderivative, we can plug in our upper and lower bounds. So the rule that we're eventually going to use is this one here. Let the entire exponent be our u value. Pull the -1 out in front. That's the leftover. Now apply your integral rule. So e to the u is just e to the u. There's a negative that's going to stay with it. We don't want to do plus c because there's upper and lower bounds involved. So bring the u back in terms of x. Now half bracket. Now work in your upper and lower bound. Upper bound always gets plugged in first. Hey, worksheet 3, review worksheet 3. Flip over a few pages. Let's look at number 4. Review worksheet, review number 3. So here, this we have a fraction here, but there's only one term below. So we can split up into individual fractions, split up into 3 separate problems, and then see what each of the rules will end up looking like. Now we do have a rule for e to the u, but it only works if e to the u is in the numerator. So this one here, we don't have a rule for 1 over e to the x, but we do have a rule for e to the x if we bring that up to the top. So now this term is just going to be e to the x, it's just e to the x. 2 becomes what? 2x. This one, that is, we do need to go through a little bit of u substitution because that is more than just an x. We got to go through u substitution, recognizing that the u value is -x, which will produce a -1, which there is going to be some leftover from this. But these first two, we can jump directly to the integral rule without having to do a whole lot. But this one, there is going to be some leftover coming out of that negative x. So e to the x is just e to the x. 2 becomes 2x. E to the u becomes e to the u, but the negative is going to stay with it. And just replace the u back in terms of the original variable. So u substitution is required here because there's a -1 that's going to be a leftover coefficient, and that negative is going to carry through into our antiderivative. Okay, so now let's flip to the page after the pages that we just did with the even and odd functions. So can we try the last what's it? Yeah, near the basically the last page here. Okay, let's start with number 6. The first thing is recognizing that this is an arc trig problem because there is a significant degree gap between numerator and denominator, right? The numerator is degree 1. We're going to ignore the square root. We're starting with degree 4. So that degree gap of 2 or more indicates that we're dealing with an arc trig rule. This one, though, doesn't require complete the square because every term is kind of set up and ready for our u and a value, but we see that this is going to be one involving arc secant because we have that u value outside and then the u value followed by the a value. So here's the rule that we're going to kind of be working towards here. So our first step is trying to get our denominator to match with the appropriate u and a value so that we can pull our appropriate u and a value so we can go through u substitution, figure out what's going to be left over. It's going to focus on what's inside the parentheses for now. We want to rewrite that 16x to the 4th to make it fit within this setup. What can I put inside the parentheses here? And 4x squared. I want to fit that 7 inside this setup here. Okay. And going through this additional step is helpful because now you're not pulling the incorrect u and a value. You know your u value is clearly just what's inside the parentheses, and your a value is that is. Okay, make your substitutions. Denominator is going to match up nicely with the rule that we're trying to involve. And then replacing dx with du over 8x is helpful because we can clearly see that our x's go away, meaning that we're on the right track here. Once the 3/8 come out, then we have a perfect match with the rule that we want to use, and then we can jump into our rule. Okay, so now we're ready. Coefficient comes first. And next up, 1 over a. My a value is 7. All right, number 7. How do we know number 7 is also degree gap? Degrees 0 and degree 2, right? So we see that degree gap. We know that we're going to be involving our trig. For this one, we do have to clean up that denominator. We do have to represent that as completing the square. Okay, factor. X plus 8 quantity squared. We can write that as x plus 8 parentheses squared. We want to fit that 3 inside the parentheses. So what can we put? 3. So now we have our a and u value identified. Remember, your a value is just the constant. Your u value has the variable in it. Right, perfect fits with arc tangent. Keep the 7, 1 over a. Arc tangent of u over a plus c. Next up, let's do this without the bounds. So cross out the bounds here. All right, what categories does this fall under? Synthetic division, yeah. But there's a bunch of degrees that get skipped over, right? So. So we need to account for all those zeros that's gonna show up in between. Power rule for the first three terms and natural log for the last term. This is a little bit more involved than just individual rules. We know we got to go through substitution, but what can we do to rewrite this problem so that there's less less things that's getting in the way? Is there any way to rewrite this problem here? We can do it that 3 there. We can do it, bring it where? In front, yeah. So this is natural log of x cubed. We know expansion property allows that x to come down. Sorry, that 3 to come down, which will make things a little bit cleaner. That 3 can just be a coefficient rather than sitting up as an exponent. So I'm gonna rewrite that. A little bit cleaner if we can see it this way. We know it's going to be u substitution. What could be our u value here? We want to have something where the derivative has a matching pair to combine with. So what if our u value was natural log of x, right? What's the derivative of natural log of x? So there's an x there waiting for it. So that'll be our best fit for this problem. Let our u value be natural log of x. X's cancel out, just like what we expected. Five, 6 comes out. And this is natural log, right? Again, I want to be reminding us that I know that sometimes we get so caught up with, we see the variable in the denominator and we always assume or just skip over the fact that it's probably going to be natural log. But again, this only works for natural log if that's u to what power? Yeah, if it's any other power, you got to bring it up and go through the power rule. Okay, this only works if it's u to the first power for natural log. All right, we have time for one more. On the page that we did even and odd functions, if you can go down to the bottom of that page and let's try number 2. But let's do it without the bounds, without the bounds. Page that we did even and odd functions. Number 2 at the bottom. Okay, too complicated for any one rule to handle. We got to think about use substitution. Let's rewrite that denominator. All right, what could be our u value? And that 3e to the x should handle itself because we know e to the x derivative is e to the x. We should be able to get that pair up for the derivative and cancel out. E to the u's derivative is just e to the u times u prime. So x derivative is 1, so times 1 won't produce anything. We should have 2e to the x. We need the x to cancel out, and they do. Pull the 3 halves out in front. Okay, what rule are we going to use here? That's power rule. We can't use natural log. Sometimes students see that u in the denominator and they feel, oh, let's do natural log there. We got to bring that up. We got to do power rule. So tomorrow, I'll give you a worksheet that has everything all more compacted, everything on 2 pages, so we can practice all of the problems together. No homework tonight, but I encourage you to start looking over your rules and also reviewing your unit circle values. Just want us to be prepared with those things in preparation for Friday. But help session tomorrow morning, 7:15 to 7:45, and also Friday morning, 7:15 till bell rings. I'll send a reminder this afternoon. Okay. Test on Friday is no calculator. Okay, no calculator Friday.
Yeah. I'm just kind of like, I mean, what's this?
Well,
Yeah.
it's not difficult to get that.
Yeah.
You fit the best. Get the class.
Yes. We're good.
This summer's costume. Already know that. Save it for you.
No, to that.
I got Yoshi. Oh, yeah. That big boss, bro. You already got it.
Yeah. Oh, we got it.
Yo, bro.
But what my like.
Yeah, but like, we're at, I just think they got. Wait, I gotta ask. I'm asking, like, I got. You haven't just sent them off.
Yeah, I'll just.
Okay, yeah, that's fine.
I did all of it. Jay, you ready for,
Oh. Hey, what's the radio?
Yeah, I hope mine should.
I ate something.
This time I can get do the program. I didn't do the last one.
Yeah.
You know, everything was put up, walking out of the.
Oh my God. I like. Yo, down. It's good.
In Bogwood.
I'm gonna go to the library.
Yeah. You're actually not taking that.
They're coming together. I'm in college already. My senior class, what?
Oh, wait.
Really? You know,
Yeah, no, actually, truly, it's not. What's it called? It's almost gonna be passion. Yeah.
Thank you guys. Have a great day.
I gotta ask.
When do you go?
I know what. I have.
Thank you. Have a good day.